For high spin complex, I am going to show here. For high spin complex, I am going to show all the calculations of CFSC. CFSC already we have discussed, just now formula is very clear. Minus 0.4 T to Z, of course M, plus 0.6 to Z, 0.6 N EZ delta N, delta naught. And for high spin complex, no need to consider any pairing energy because the pairing energy from the both will get cancelled. Let us calculate this one d1. d1 means, so obviously here the electron is going to fill here. Even before also electron is going to fill where? Electron is going to fill here only, and here also it is going to fill here only. So what is the formula now? Minus 0.4 into M means how much? 1 into plus there is no easy 0 delta naught. So it is going to be minus 0.4 delta naught for which one? For d1 configuration and in high spin complex. So I will show here in high spin complex d2. d2 same way, if you are considering here 1, 2. Once after splitting, it is going to be 1, 2. And here there is no electron. So 2 means minus 0.4. CFSE is equal to minus 0.4 into 2 T2Z plus there is no easy electrons, right? 0 delta naught. There is no pairing concept in the particular high spin complex because both will get cancelled. There is no pairing, there is no pairing. So 0, right? So here, if you are considering here minus 0.8 delta naught, obviously it is equal to 8 dq. Right? Here it is going to be 4 dq. Already we have discussed delta naught is equal to 10 dq. So let us discuss about T3. D3 is going to be 1, 2, 3. 4, 1, 2, 3, third electron enter here. After splitting also the electron is going to be in the same way 1, 2, 3. So actually for high spin complex or low spin complex from D1 to D3 the CFSE is going to be same. That I am going to show you here only, right? And here 3 electrons are there, minus 0.4 T2Z. How many electrons are T2Z? 3 plus there is no easy electrons, 0 delta naught. How much is going to be? Minus 1.2 delta naught is equal to how much already we are discussed? It's going to be discussed as CFSC crystal field stabilization energy. In the end we will not write in the negative value, we will show you positive value only, and it is going to be 12 dq. Thus, let us see the same d1, d2, d3 in strong field also, so that comparison will be easy for us to strong field. See whether if it is d1 electron, d2 electron, d3 electron, if it is strong field or weak field, the electron will enter into here only, T2Z only. Why? Because the pairing concept will not come under for d1, d2, d3 concepts. So here you can see I am writing here first electron here. Two electrons here. This is degenerate topic we are going to talk here. 1, 2, 3, 3 electrons are here. So these 3 electrons concept we are talking, 2 electron concept we are talking, whether it is strong field or weak field, the electron will come under here only. After splitting, the electron will come under here only, and the CFSC will be same. It must be very clear. Why CFSC is same for D1, D2, D3? Because whether it is after splitting or before splitting, the electron will enter into the T2Z level only. T2Z 3 electrons, T2Z 2 electrons, T2Z 1 electron. Here the pairing occurs after 4th electron. So CFSE for whether high spin or low spin, the energy is going to be same. We will make a table in the end by using these values. How much it is? 4 dq, 8 dq, 12 dq. Now, if it is 4th electron, that is d4, that time only whether it is high spin or low spin we have to worry. For d1, d2, d3, whether it is high spin or low spin, the CFS is going to be the same because there is no pairing concept here. Now, we are going to discuss about d4, d5, d6, d7 in high spin and low spin, right. Here I am going to show you high spin, here I am going to show you low spin for d4. For d4, if you are considering, it is going to be how much? Obviously, it is going to be 1, 2, 3, 4, 5. 5 d-orbitals, 1, 2, 3, 4, and this is going to be empty. Once of splitting, how much is going to be? It's going to be T2Z. It's going to be easy, right? T2Z, 1, 2, 3. As it is a high spin complex, we have to enter the electron in the higher energy level. The same way, for low spin complex, the electron will enter where, Amma? The electron will enter in low spin only. The electron will enter here only. In this one, if you are seeing, the T2Z will come 4 and EZ will come 0. Here T2Z 3 and EZ 1. Right? Now let us calculate CFSE. CFSE, how to calculate? CFSE calculation already we have discussed. For high spin, the pairing energy concept will not come because here before and after pairing this will be equal. Now here it is going to be different. For CFSE, here minus 0.4 M2 plus 0.6 NEZ delta naught concept here. Now we are going to consider minus 0.4. How many electrons? 3 electrons. Minus 1.2 plus how much is going to be? 0.6 into 1, 0.6 delta naught. How much is going to be? It's going to be minus 0.6 delta naught. Obviously, it's going to be, if you are multiplying with 10, it's going to be 6 dq because we have discussed that delta naught is equal to 10 dq. Right? Now, where in the case of low spin, the same formula, it is going to come but minus 0.4 T2Z M plus 0.6 N EZ delta naught. How many pairs are there? Before low spin, there is no pairs, right? At degenerate level, there is no pairs. 1, 2, 3, 4. So, at degenerate level, there is no pair. And so, it will come as 0 pair here. Isotropic field. At after ligand field, how many pairs? 1 pair. So, 1 pair will come here. In the case of low spin, we have to consider pair here. In the case of high spin, no need to consider pair because they both will be same, it will get cancelled. Here both will not be same. So, 1 pair will come into picture here. The same concept here, if you are considering minus 0.4, how many T2Z electrons are there? 4. 4 EZ electrons are 0. Delta naught. Right? Plus pairing energy. So, here if you are considering minus 1.6 delta naught, that is going to be 16 dq. Right? So, 6 dq here, 16 dq here. In case of low spin, minus 1.6 delta naught plus we must consider P. We should not forget P here. There is no pairing concept here. High spin concept, no pairing. Now, same way I am going to show you D5. Once after making all these things, we will make a table so that it will be clear for us to understand, right? D5. D5. Now, I am going not, D5 is here. 1, 2, 3, 4, 5. T2Z here, EZ here. Now I am going to show you directly, not even filling, directly we can show T to Z, sorry. T to Z here is. Now 5 electrons, right? 1, 2, 3. No need to pair because it's high spin complex. Whereas in the case of this one, you have to pair. 1, 2, 3. Fourth electron pair, fifth electron pair. Easy, no need to have any electrons here. Right? And here, if you are considering here, now CFSC calculation, to calculate CFSC, how to calculate CFSC? Minus 0.4 M2 to Z plus 0.6 N2 to Z NEZ delta naught. So let us see here how many electrons are there? 3, and EZ 3 electrons minus 0.4 into EZ. T to Z how many electrons? 3 plus 0.6 how many electrons here? 2. Total is going to be delta naught. There is no pairing energy concept here. Minus 1.2 plus 1.2 delta naught. Very important word. CFS is going to be 0. Whereas for this one, that is for strong field complex. Cis 1, how much? Minus 0.4. T to Z how many electrons? T to Z how many? 1, 2, 3, 4, 5. T to Z 5. EZ how many electrons? 0 electrons. So, into 5 plus point, there is no electrons, right? 0 delta naught. How many pairs are there before? How many pairs are there? There is no pairs. There is no pair at degenerate level. So, it is going to be 0 pair. After ligand centering, how many pairs? 2 pairs. Right? And so it is going to be 5 4s are 20 minus 2.0 delta naught plus 2 pairs. So this is going to be CFSC for how much? For D5 configuration. D1, D2, D3. Whether it is high spin or low spin, it will be same. D4. We have seen already D4 configuration here. Now for D5, it is going to be 0 for high spin and going to be minus 0.2.0 delta naught plus 2p. This is going to for D5. Now moving on to D6, because we have to discuss from D1 to D9 both for strong field and weak field. D6 high spin. How many electrons are going to come now? One, two, three, 4, 5. Sixth electron. 1, 2, 3, 4, 5 and 6. Right? Here we can see pairing. One paired electron after ligand approaches, one paired electron before. So no need to discuss about pairing here. CFSC calculation we have to see minus 0.4. How many electrons are there in T to Z? Let us write the configuration like this. T to Z how many electrons? 4. EZ how many electrons? 2. So this is the simplest electron configuration after crystal field stabilization energy for calculating, right? And how many are there? 0.4. T to Z how much? 0.6 into 2. This is going to be delta naught. How much it is going to be? 4 4s are 16 minus 0.16 plus 1.2 overall delta naught. It is going to be minus 0.4 delta naught, that is going to be 4dq. The same way if you are considering here, right? Here the splitting is going to be how much? 1, 2, 3, 4, 5. Right? So let us fill electrons here. Once after filling 3 electrons, we have to pair because it's going to be low spin. In low spin, we have to pair. And now, third and fourth electron here, fifth electron here, and sixth electron here. And easy, there is no electrons. So what is the electron configuration? T to Z में 6 and easy 0. So CFSC calculation, if you want to consider before ligand enter, how many electrons are paired? 1, 2, 3, 4, 5, 6. Only one is paired. So CFS is equal to minus 0.4. T2Z how many electrons? 6 plus 0.6. How many electrons in EZ? How many electrons? 0 into delta naught. How many pairs are there? How many pairs are there here? 1, 2 plus 2 pairs. How many pairs are before? Sorry, not 2 pairs, 3 pairs is going to be. How many pairs are there here before? 1 pair. So it's going to be 2 pair. Right? Here it is going to be 6 4 the 24, 0.24 plus is going to be 0. Right? And so it is going to be delta naught. 2.4 delta naught plus 2p. So this is the calculation for D6. D6 we can see here the configuration CFSE here. In the same way we can calculate D7, D8, D9 also. Very interestingly, like D1, D2, D3, it will be same once after reaching to D8. That we can see here now. D7. I am pairing here. D7. 1, 2, 3, 4, 5, 6, 7. Right? High spin same. 1, 2, 3, 4, 5, 6, 7. Right? Here for low spin it is going to be how much? 1, 2, 1, 2, 3, 4, 5, 6 and 7th electron is going to enter here. So let us write configuration like this. T2Z easy. So how many electrons are there? 1 to 5. Easy 2. T2Z here 6. Easy 1. Now easy to calculate CFSE here. CFSE already minus 0.4 into T2Z. How many electrons? 5. Plus 0.6 into easy. How many electrons? 0.6 into easy. 2. Delta naught. It is going to be 0.2, right? 2 plus 1.2 delta naught. How much is going to be? Minus 0.8 delta naught. Obviously 8 dq. In the case of this one here, CFSE is equal to how much? CFSE we can calculate like this, right? It is easier to calculate also. Minus 0.4 into T2Z. How many T2Z is? 6. Plus 0.6 into EZ. How many EZ is? 1. Delta naught. Right? How many pairs are there after ligand approaching? How many pairs are there? 1, 2, 3. 3 pairs. Right? How many pairs are already there before ligand approaching? 1, 2, 3, 4, 5, 6, 7. 2 pairs are already there minus 2p. Right? And here 24, 2.4 plus 0.6 delta naught plus 1p only. If you are looking it carefully here, right, it is going to be how much? Minus 1.8 delta naught plus 1p. This is the calculation of CFSE for D7. D7 if you are looking at carefully, it is going to be different only. Only D1, D2, D3 came same. From D4, D5, D6, D7 came different. Now we are going to see D8 also for low spin and high spin complex. D8 configuration. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Once after splitting, right? How many electrons here? High spin 1, 2, 3, 4, 5. High spin, right? 6, 7, 8. T2Z how many electrons? 6. EZ how many electrons? 2. Right? So T2Z 6, EZ 2. Let's see same way for low spin complex. For low spin complex, if you are looking at low spin complex, it is going to be 1, 2, 3, 4, 5, 6 and 7th electron is going to enter here, right, and 8th electron is going to enter here. T2Z how many electrons are there? 6. EZ how many electrons are there? 2. So this is if you are looking carefully here, T to G6 Eg2, T to G6 Eg2. Both the things are going to have same electronic configuration, and so CFS is going to come as same. Why? Because minus 0.4 T to Z, how many? 6 plus 0.6 into Eg, how many? 2. So obviously this number is same here and here also. Minus 0.4 into T to Z 6 plus 0.6 into Eg, how many? 2 delta naught. So this number is going to be same, and so CFSE is going to be same. Interestingly, the pairs 1, 2, 3 pairs here, 3 pairs here. Anyway, here we will not consider pairs. Here 1, 2, 3 and pairs are same. So it is going to be 3p minus 3p. So this will get cancelled. This will get cancelled, and so this CFSE, how much is going to come here? 24 minus 2.4 plus 1.2 delta naught. How much is going to be? It's going to be minus 1.2 delta naught. That means 12 dq. Same way here also it is going to be minus 24, yeah, 1.2 delta naught is equal to 12 dq. Very important point, for D1, D2, D3 the CFSE came same, and D8 also came. Only 2 more configurations are there, D9 and D10, that I am going to show now. For D9 configuration, high spin here 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? After splitting, what's going to happen? 1, 2, 3, 4, 5, 6, 7, 8, 9. That means T to Z how many electrons? 6. EZ how many electrons? 3. So it's going to be which configuration? T to Z 6, EZ 3. Let us write for low spin also in the same way. How many electrons? 1, 2, 3. We have to pair immediately, right? 4, 5, 6, 7, 8, 9. Right? T to Z how many electrons? 6. EZ how many electrons? 3. We can see here both are going to have same configuration, and so both are going to have same CFSE. CFSE, what is the CFSE formula? Minus 0.4, how many? 6 plus 0.6, EZ how many? 3 delta naught. The same will come here also, because the pairing CFSE will come same here also. Pairing how many? Before also 4 pair, after also 4 pair. 4p minus 4p. 0 will come. We will enter this value from here itself, because both are going to be same. 6 4s are 24, 2.4 plus 18 delta naught. How much is going to be? Minus 0.68 6 dq. Same minus 0.6 delta naught is going to come here 6 dq. So for D9 configuration also CFSE is going to be the same. For D10 it is very easy. D10, whether it is high spin or low spin, T2Z electrons are going to be how many? T2Z electrons are going to be 6, EZs are going to be 4. Same way T2Z is 6 and EZ is 4. What will happen? Minus 0.4 into how many electrons? 6 electrons plus 4 into 6 electrons, 4 into 0.6. So both the numbers are going to be same. CFS is going to be 0. Here also CFS is going to be 0. For D5 and D10, CFS is going to be same, that is 0 for high spin and low spin complex. From this we can make a complete table. That table I am going to show here, in which we are going to show from D1 to D10 for low spin complex and high spin complex. So here, once after calculating complete DN configuration CFSE from D1 to D10, this is the summary of the D1 configuration to D10 configuration for high spin and low spin complex. Here you can see for D1 and for D1, whether it is low spin or high spin, For D2, whether it is low spin or high spin, for D3, whether it is low spin or high spin, the CFS is going to be the same. So, same way, whether it is D10, it's going to be 0. Here we can see from D9, it is going to be same. The same way, D9 and D8, it is going to be same, right? So, which are going to have same configurations, same CFSE, D1, D2, D3, D8, D9. Obviously, D10 is going to be 0 only. D1, D2, D3, D8, D9, whether it is low spin or high spin, the CFS is going to be 0. And in the case of low spin complex, we will not consider pairing energy because both will get cancelled, whether it is after pairing or before pairing, the pairing electrons will be same, it's going to be at 0. Here the pairing electrons will enter the picture. With this one, we have completed the CFSE calculation for D1 to D10 configurations in high spin and low spin complex.